Welcome to my video for motion problems. Motion problems are an application for systems of equations. So in these problems that you see, we're going to be using the things that we learned in the last chapter in order to solve systems of equations. Before we get started with systems of equations, we need to know a very special equation, which is distance equals rate times time. If you haven't written this down yet, I suggest that you please pause the video, get out a piece of paper and a pencil, and write this down. I'm going to be going through an example, and it's important that you have it in your notes. Motion problems are going to be word problems, and that means that you need to make sure you slow down and read each problem and try to understand what's happening in the problem before you try and solve it. One way of doing this is to read through the problem and then draw a diagram. I'd like you to pause the video, read through the problem, and draw your own diagram. So here's my diagram. I've used red to represent the passenger train, yellow to represent the freight train, and I've drawn arrows indicating that the trains are moving in the same direction, and between them I drew a train track just to remind me that they are trains. Now, in this problem we're given a lot of data, and we're going to need to organize this data into a table. So each row is going to be dedicated to an object. Well, I have object 1, object 2. In this case, our two objects are a passenger train and a freight train. My columns are going to be the variables from the formula from the last page, which was distance, rate, and time. And you'll recall that distance equals rate times time. We're also given some information about each of these variables, about distance, rate, and time. Since the two trains are trying to catch each other, the distance that the two trains will have gone will be equal. So that's important to know that the distances will be equal. So we're going to make a note of that. I'm given a bunch of confusing information about time. I know that one train leaves 2 hours after another train, and that the freight train and the passenger train meet in 3 hours. So I'm going to use this information in order to fill in the boxes for time. So I know the passenger train is going to overtake the freight train in 3 hours. So I'm going to put a 3 for passenger train. I also know that the passenger train left 2 hours after the freight train, which means that the freight train has been going for 5 hours. And I know this because it took 3 hours for the passenger train to catch the freight train, and the freight train basically got a 2-hour head start. So that's 3 plus 2, and that equals 5. I'm also given information about the rate, and it's not quite as clear as the information we were given about the time. I know that the freight train is traveling 20 miles per hour slower than the passenger train. So that means that the passenger train is moving at a rate that we call r. The freight train is moving at a rate r minus 20, because it's moving 20 miles per hour slower than the freight train. And this makes sense with our problem, because the freight train has been going for 5 hours, and it has to be going slower if the passenger train is going to catch up to it. Now we can use our equation, distance equals rate times time, to fill in our distance box. So our rate is r, and our time is 3. So rate times time is 3r. For the freight train, the rate is r minus 20, the time is 5, which means that the distance is 5 times r minus 20. Since I know the distances will be equal, I can then set up the equation 3r equals 5 times r minus 20. This is one equation with one variable, which means I can solve it fairly easily. I get 3r equals, and now I have to do the distributive property, 5r minus 100, and I get r equals 50. So I know the passenger train is going at 50 miles per hour, and the freight train is moving 20 miles slower, which means that it's going at 30 miles per hour. Again, if you haven't already, you want to pause the video and make sure you have this example in your notes. Our final solution was 30 miles per hour and 50 miles per hour. So what I expect to see tomorrow when I check the homework is 1, distance equals rate times time. This will be worth 2 points. Second is the full example. Which will be the other 2 points. And by full example, I mean that you have each step, you have the table written out, you have the equation solved, not that you just wrote down the final answer. In addition to these 2 things, the first person to email me the correct answers for the last problem will get 1 point of extra credit. I look forward to talking about motion problems with you more tomorrow. Have a nice afternoon or evening.